So this is the third case related to 2's complement operations, where one number is positive and one is negative, but here the magnitude of the negative number is greater than the magnitude of the positive number. Okay, so let us consider the arithmetic operation 59 minus 96. Okay, this is the arithmetic operation. So we will convert it into this form: 59 plus minus 96, converting it into addition. So that is the main concept behind 2's complement arithmetic operations. In digital circuits, almost all the arithmetic operations which are performed, they're done using 2's complement arithmetic and converting it into addition. Even the subtraction is converted into addition. So here 59 will be represented as usual using sign magnitude, as we do to convert it into binary equivalent, and minus 96 will be represented in 2's complement form, sign binary number, negative number. So here first is plus 59. Splitting it into the respective powers of 2, we have 56 plus 3, 56 is 48, 30, okay. 32 plus 16, which is 48, okay. Plus 8, which is 56, okay. Plus 2, which is 58, plus 1, which is 59, okay. So now 32 is 2 to the power 5, 16 is 2 to the power 4, 8 is 2 to the power 3, 2 is 2 to the power 1, 2 to the power 0. Again, if you have any confusion related to this, you can use the repeated division or the LCM and remainder method to convert any decimal number into binary. Okay, the usual process. But if you get used to this method, you can easily convert any decimal number into binary just by splitting them into the respective powers of 2. So now if you have to represent it using 8-bit format, it is 2 to the power 7, power 6, power 5, power 4, power 3, power 2, power 1, power 0. Okay, so here 2 to the power 5, it is 1, 4 is 1, 3 is 1, 2 to the power 1, that is 1, 2 to the power 0 is 1, and remaining all are 0. Okay, this is plus 59. Again, as you see, the sign bit is 0, so it is a positive number. Next is, okay, here let us do. Next is 96, minus 96, but first we have to represent plus 96 and then we'll take the 2's complement to get minus 96. So this is very easy, simply 64 plus 32. So that is 2 to the power 6 plus 2 to the power 5. So here for plus 96, it is 2 to the power 6, 1, and 2 to the power 5, which is 1. Remaining all are 0. Okay. This is plus 96. Now we have to represent plus 96 using minus 96 using 2's complement form. So 2's complement is 1's complement with 1 added to the LSB. So here first we have to take the 1's complement. It will be 0 will be changed to 1, 1 will be changed to 0. So 1 0 0 1 1 1 1 1. Okay, now this is the 1's complement of plus 96, the binary representation of plus 96. Now when we add 1 to the LSB, we have 1 plus 1 0 with a carry of 1, 1 plus 1 0 with a carry of 1 plus 1 0, carry of 1, 1 plus 1 0, the carry of 1, 0 with a carry of 1, 1 plus 0 1, 0 1. So we have 1 0 1 followed by 5 zeros. This is the 2's complement, and this is minus 96 in 2's complement form. We have to do 59 minus 96 or 59 plus minus 96. So now for the final arithmetic operation, we have 59, which is 0 0 triple 1 0 double 1. Okay, 32 16 8 10 2 1. Okay, next is minus 96 in 2's complement form, which is 1 0 1 followed by 5 zeros. Okay, this. So this is 59 minus 96 addition. So we have 1 plus 0 1, 1 plus 0 1, 0 plus 0 0, plus 0 1, 0 1, 1 plus 1 is 0 with a carry of 1. Then here it is 1, 1 plus 0 plus 0 is 1, and here 0 plus 1 it is 1. So this is the result. Now 59 minus 96, the result is minus 37. Now we have to see whether this binary representation is also minus 37. So for that we have to convert it into decimal form. So here the MSB bit, or the sign bit, that is 1, so obviously it is a negative number. So we'll attach a negative weight to this sign bit, so it will be minus 1 into 2 to the power 7 plus 1 into 2 to the power 6 plus 1 into 2 to the power 4, 1 into 2 to the power 3 plus 1 into 2 to the power 1, 1 into 2 to the power 0. This is the decimal value. Now if you remember, in 1's complement for negative numbers we add a plus 1 to the final result in 1's complement, but here we don't add any 1 at last. In 2's complement we don't add 1. So this is equal to minus 128 plus 64 plus 16 plus 8 plus 2 plus 1. So it is equal to 128 plus 64 plus 16, that is equal to 80, 88, 19, 91. 128 plus 91, which is equal to minus 37. Okay, this. So here is also minus 37. Here also it is minus 37 in decimal form. So both sides they are equal. It checks out. So it is the correct result. It is the correct binary representation of minus 37 in 2's complement form. Okay, so this is the thing.